Hi guys, this is the video on the how we declare a new architecture in MythSim. And so this is the architecture we've been working with, the accumulator.u code. Okay, so each pretty much everything except for the go-to commands are signals in MythSim. So if we go into MythSim, where's MythSim? There it is. And we look, uh, each of these guys, one of these controls uh, what goes onto the A bus, VA, B, VA, A cell. This is B cell. This is R0 right, R1 right, R2 right, and so on up to R7 right. And all of these wires exist simultaneously. They all are happening at the same time, which means that it doesn't matter what order we write on each line, we control every line. If we don't say it, it gets a default value, like CN will by default be 0. Uh, okay, there's a, uh, this is the control for the ALU. Okay, so these wires are all control wires in. There's a control wire that controls which result comes after the ALU bus, and these read and write are control wires. You get out of it, uh, data wires are coming out. C out, M7, V, and wait are all data wires that can come out. Uh, there are also some control wires for the MAR, the MDR, and these guys, telling them whether they should read from the various wires coming in. So the MDR can get from memory, it can get from the ALU, it can get from various other stuff. So all of these are control wires. Now, so what are these controls? Well, so R4 right tells us that we're going to take whatever's coming from the uh, from this guy, from the results selection, and write it to R4. That's the accumulator. So all of these opcodes will write a new value into the accumulator. Now, A cell 4, B cell 4 reads the accumulator and runs an XOR on the ALU. Now, if you remember right, XOR, when both things are equal, always returns 0. So what it's going to do is make every single bit 0 and write it to the accumulator. Namely, it makes the accumulator equal to 0. Okay? Now, R4 right, once again, we're changing the accumulator. We're reading from the accumulator into the A, and we're putting a 1 in CN. And in this case, we're using ADDA, which means we're going to add CN into the A bus, and that's going to put one increment the accumulator by 1. This one also writes the accumulator. It reads from the accumulator, and it subtracts from the A bus 1. If you put C in this one, it would subtract 0. But since we didn't, it subtracts 1. And all of these end in go to fetch 0, which is go to the next instruction. Here's the fetch code. We'll talk more about that. That's a little complicated. It's hard to read, so I'll talk about that later. Now here's our 4. Once again, we're writing to the accumulator. We're running not, so we're reversing all the bits. And opcode 5, we write to the accumulator, we read from the accumulator, and we're running not, but in this case, we go to negate. So we're not going to fetch 0, we need to run one more line. We go way down here to instruction support, we have negate, which is Okay, so remember, two's complement negate means we not all the bits and then we add 1. And here is the instruction where we add 1 to the ALU. So we combine. So negate combines. Instruction has 2 lines that combine opcode 2 and opcode 4. So we do the same thing as opcode 4, and then we do the same thing as opcode 2. So sometimes we need more than one instruction. A lot of things we can do with just one instruction, but sometimes we need more than one. Okay, so opcode 6 doesn't writes to a specified register. So if you remember right, stuff like this guy, when we see there's a few opcodes where we specify the target, and one of them is opcode 6. So here is an example of instruction that's writing to R3, and it writes to R30. There's going to be another instruction, uh, this one, that also writes to a register, but this time it writes from memory. So we'll talk a little more about that later. Let's go back to the accumulator code. Okay, so in this one, we select the accumulator and we write it to the targeted register. And that's all it does. This one takes register 0 and writes it to the accumulator. This takes register 1 and writes it to the accumulator. This takes register 2 and writes it to the accumulator. This takes register 3 and writes it to the accumulator. All of these just move numbers. There's nothing else going on in this code.